Hello everyone, new calculus video, and on today's video we will be learning about the intermediate value theorem, okay, or shortened for IVT. A very cool initial, IVT, okay. Well, anyway, so to solve the intermediate value theorem, that is just basically proving how for a function like this one from the interval of 1 to 2 that you can have this function be equal to 0 and find for the value of x, okay? Normally that's really hard. I mean, come on, if you are given a function of x to the power of 4 plus x minus 3 be equal to 0, can you solve the value of x? Well, of course that's going to be a little more than 1, but then it has that, so everything gets complicated, okay? So to solve this problem, okay, what do? But before that, to solve this problem, okay, this video is going to be too short, and I want you guys to know much information as you guys can get. So I will have another example for you guys where I will set the function be equal to, okay, I got a good one. It's a really good one. 2 plus x minus 2 times x to the power of 2 from the interval from 2 to 4. All right, that's a really good one. Okay, so to solve this, right, how can I prove that there is a value of x that if you put it in there, we get 0 from this function? Okay, it's really hard. It's really hard. And I don't even think I set this function right. Did I? I don't know. I don't know. So I'm probably going to have to make a new function. Okay, like, for example, okay, L and X. Okay, this is really bone chilling. This is really good. Okay, so how can I find the value of L and X that is equal to 0 and find it for the value of X? Right? That's really hard. Wait, no, actually X can be 1. Okay, it cannot be that. It has to be something really hard. Okay, I will just like this. Okay, this one's really good. Okay, it is really hard for you to find the value of x where if you put it in there we get 0 from this function. Okay, well, now to start off with this problem, okay, let's draw a simple graph where x is equal to 2 to 4. So 1, 2, 3, 4, 2 and 4. Okay, so basically we just put in the value of 2 into there. Okay, if I put in the 2 into there, I get 4 plus 4 minus 5. What is that equal to? That's equal to 3. It's right here. And now when I put in the value of 4, put it in there. Oh, this cannot work. I will just put a -1 there, okay? Okay, so now let's restart this. This is really hard making up a question, if you guys didn't know. Okay, anyways, let's put in the x is equal to 2, put it in there. We would get -4 plus, actually, I'll put a plus there, okay? That's better. Okay, so when I put in the value of x is equal to 2, put it in there, I get -4 plus 4 plus 5, okay? That's 5. That is 5. Right. So at this point. And now let's put in the value of x is equal to 4 into there. I get -16 plus 8 plus 5. You get to -3. 1, 2, 3. Okay? And that is in the interval from 2 to 4. So there is no other way that from this point to that this point can travel to this point without touching this. Okay, that's what the intermediate value theorem is. Okay, it proves that this can be actually be equal to 0 for a value of x. It can. Okay, so this proves it. Okay, that's really cool. So it can travel like this. It can travel like this. It can travel like this. Any way that it can. There is no way that this point it can travel to this point without crossing this. But you may ask that it can go like this. right? But listen, can a function look like this? No, this fails the vertical test. Something like that. It's something like that called, okay? This is not a function because it crosses the vertical test. Okay, so this function is not allowed. And there is no function that actually looks like this, or anyway. So, okay, we just have proven that this value can be equal to 0 for some value of x, okay? So now that we have solved this, let's solve this one. Okay, again, we start off with a graph from what to what? 1 to 2. So let's call this 1, this 2. Okay, so let's put in the value of 1 into there. We get -1. Okay, we get -1. And when I put in the value of 2 into there, that's 16 plus 2 minus 3. So that is equal to 15, okay? I know it doesn't look like it, and we don't have the room, but let's just call this 15, okay? From the interval from 1 to 2. So, wait, no, it's actually this point. Oops, my bad. Okay, so again, we have proven that just by graphing this simple thing, we know that there exists a value of x, which if you put it in there, we get is equal to 0. Okay, that's real cool. So in any way it will cross this x is equal to 0, no, y is equal to 0, and yeah, it's really, really cool. So to sum up of what I just did, if you guys cannot remember or just think about my video when you guys are having a test or something, then you guys can always look at this note. It's very long, but in your guys' own way, you can shorten this out, okay? Just think about that. The function always has to be continuous, and it has to be in the interval from a to b. Okay, that's real simple. A continuous function from a to b. And a number between a and b, they always have to be different, okay? Because if I call this a and that's b, okay, that makes sense. It can cross a 0. But if they're the same, like what? No. But if they are in the same quadrant, it can never go past that. I mean, you can do it this way, but what about this way? So yeah, they always have to be like this. And there exists a number c from a to b, a to b. See? The c can be here, 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 anyway. So, thank you guys so much for watching my video. So, see you guys in the next video. Bye.